Welcome everyone to the very first virtual SI session for CS46a. So we're gonna start off with the agenda right here. So first of all, we're gonna start off with some logistics. Like we're gonna be covering like how a virtual SI session works, like outside of the session itself, but also inside the session, like what the students are expected to do, what the format is going to be like. So I guess I'll cover that right now. Okay, so pretty much whenever you join the chat, right? Not the chat, well, the session, you don't really need to use your mic. You don't need to use your camera. Of course, like it's for your privacy, but also because that way Yen and I can be heard at all times. So for the most part, all the students are expected to just only use the chat whenever they have questions. So the way it's going to go is that Yen and I are just going to run through the whole session with just us two. And if you have any questions and get confused along the way, then you could just ask a question inside the chat. It's recommended that you do follow along with your computer as we go, and see if you can find out maybe like a better solution, a better suggestion, or maybe like another way of doing it, or maybe you get stuck and then you see that we're doing something different and you wonder why. So that's pretty much the idea behind it. And of course, like questions are welcome anytime, but keep in mind that sometimes we might be covering something, so we'll wait a bit before we answer it. And then as for the actual videos, we'll pretty much be emailing the videos to you if you show up on the session. So as soon as the video is ready, then we'll have it out to you. So making the video can take up to about a week, probably at most, depending on how our video editor, how fast he does it, basically. And if it's about 2 weeks before the exam, maybe, yeah, just about 2 weeks, maybe a week, then we'll have all the videos out to everyone, not just the people who showed up. So then that way everybody gets to be able to see it at the end. If you want to get participation points for the virtual SI sessions, just make sure you do actually like properly put in your actual ID, your actual name, and that you don't make any typos. And then make sure you stay in the session for about 30 minutes, because we do try to keep an eye on everyone, so you don't just like show up at the beginning and then leave after 5 minutes. So that is the requirement. Okay. So I actually wrote a little bit of code here ahead of time. So you don't have to necessarily code this yourself, but this is just for visual reference for everyone who wants to just see it line by line, right? So in the case of a for loop, if everyone remembers, the way we write it is like this. So we say int, and then we say number of actually, we could just say int I equals 0, and then we say I is less than the number of times to loop, and then we say I++. So so a lot of times we usually just follow this format, but people could be like, all right, what does this mean? What does this mean? What does this mean? Well, in a sense, you can see like this is the starting point of the loop, right? Like, all right, this is where the loop starts. And then this middle part over here is where the loop ends. So it's the ending point of the loop, right? And then this is the step that happens every in between of the iterations of the loop. So this is like what happens to the starting point and how you progress through it towards the ending point. So in this case, a for loop is really well structured, so that right now, like I have it so it will always happen 10 times. Whatever stuff happens here, like whatever code I have inside here will happen exactly 10 times, just because of the way this works. Like I start as 0, then it ends after doing whatever is in here 10 times. And that's because I always go up by 1. If I said like, okay, I increment by 2, then it should happen about 4 or 5 times, depending if I go out of bounds or not earlier or not. But it should happen about that many times. But for the most part, yeah, that's the idea of a for loop is we know how many times we want to iterate. So it's easier to just say, okay, just start here, end here, and just go this many times, and go towards that end goal this fast. So that's the idea of a for loop.
So as you can see from a for loop that Mark had just did or explained, you can also convert that while for loop into a while loop. And you can do the same thing as in initialize the starting point, check the conditions, and then you increment that variable that you initialize outside of the while loop. So a while loop in here, in this case, can be a for loop if it wanted to, if it wants to. And another case that while loop can cover better than a for loop would be the case where you use a Boolean value. So on the line 15, you see that while not done. So what is happening here, which is, if you notice the Boolean value before that saying something happened, wait, not done, variable done equal to false. So right now is false. So the opposite of done is not done. So while true is what it means on line 15. So since it's true, it will execute whatever inside a while loop. And then you go to if something happened is true based on the content of the variable. And so you go inside again with inside the if statement, and then you assign true to done. So you replace done value with true instead of false. So now you go outside of a while loop after this one iteration. Done now is not true. So now is false. So it stopped right after one iteration. So in this case, you don't need to increment or decrement with the while loop, but you can manipulate the value of Boolean. And so you can check certain condition and you stop right away when you found your value. So this is the case where you find your value after, let's say, one time. So you stop running the while loop right away. But you cannot really do that with a for loop, because what do you do with the last requirement when you initialize it, which is like the I++ or whatsoever. So in this case, a while loop can cover things that a for loop cannot do and more.
Now we're going to talk about a strange way to divide. So we made up this problem just as a way to like let's say practice loops. So this is not really like a normal real life situation thing that you'll always see every day, but it's a good way of thinking about how to use loops, for example. So let's say we're given an even number. What's a way to find half the dividend without using a division operator? So there's a lot of mathematical terms here, but to explain what I mean by that is, let's say we have A, right? And we wanted to divide it by 2 to get C. So what I'm saying is, I want to write a program where if I say a number A, then it should return A divided by 2 without actually using a division. So like normally in my code, I would do something like this, right? Like if I was allowed to use division, it would be something like this. So let's say I want to use a scanner. So then that means import java.util.star. And the easiest way is scanner scan equals new scanner system.in. And I say scan, oh, actually, double, I'll say number, I guess, and then scan dot next double. So then I would just say, actually, I think it might be double. Yeah, there you go. Okay, double result, or actually quotient, because that's technically the result, equals number divided by 2. So this is the easy way, right? And then saying system.print line, and then results, and then I print out the quotient. So this is the normally easy way to do it. Well, let me print out the question too. Oh, I forgot. Dot out. Out dot println, and then system dot out dot println, and let's say the question would be something like, give me a number. And actually, it should just say print. Right? So it would say, give me a number, then you take half that number, and then you print that result. So that's what it's trying to do. And let's check if it works first, just to make sure. So let's say 10. It should print out 5. Okay, so it works great, but in our slide, we said we are not allowed to use the division operator. Like, can we do this in a way without actually using divide?
So there are 2 ways that you can approach this question. So first, I will approach with the way that I thought. So in this case, the trick is not to use division at all, but you can use addition, multiplication, or subtraction. So what I thought of was use subtraction instead. So say given a number from the user, I will first make a for loop. So because I know the end result is from the given number that the user gave me. So let's just start from the number that the user gave me.
Okay.
So it would be number.
Right here?
Yeah. So do you know in this case it's just number? So
I'm not.
Double number in inside my for loop, inside the for loop.
Oh, okay, so I could just say number is what you're saying?
Yeah. You can put that. And then the next condition would be number greater than or equal to 0. Greater than or equal to 0.
Oops, my bad.
And then number minus 2. Number equal to number minus 2. So what happened in this line is that
Actually, I think what we should do is just int I equals number, and then I could just say I for all of this.
It's a double.
Oh, right. Probably works for doubles too. Yeah, I'll get there.
So what has happened in this line is that given the number that the user gave me, let's say a 10, and I will have that 10 run as many times as the condition remains true, which is greater than or equal to 0. So every time that number is greater than or equal to 0, my I will give decrement to every time. So now in the for loop, I will check if I now is equal to 0. So if it's equal to 0, oh, and also before the if, I would want to do the count. So can you initialize the count for me? The count.
Just say an integer count equals 0.
Right.
Right before or afterwards?
I would do after. So after the if. Actually, let us do before.
Okay.
All right. So now if count equal to 0, then that means I reach the end. Then I would want to print the count.
So instead of doing this over here, we can do it right here.
Actually, in this case, then I wouldn't need the if at all. So let's just remove the whole if in general.
Okay. So let me just get rid of this.
Yeah. Then in the end, I would do count instead of quotient.
Like that?
Mhm.
Okay. So when I look at this for the first time, right? Like I don't really know what's going on. So how does this give me half of the number I'm given?
All right. So let's going over it again. So in the beginning, can you also like do side comment as I say along?
As a what?
Yeah. Just write like the number, like tracing it.
Okay. Okay. So let's say we're gonna go with 10.
Okay. So number right now is 10. You go into the for loop, I equal number. So that means I is 10. And then is I greater than or equal to 0? Yes, it is. Then we go inside and we count. So now count is 1. In the beginning it was 0, but now it is 1 because the condition is met.
I'm having trouble finding the pen right now. Okay, there we go. So C equals 1. There you go.
All right. So now before you go to the next iteration, U minus I. So I now is 8. All right. And so you check on the condition again for the second time around. 8 is greater than or equal to 0. So you go inside the loop again one more time. You count, and now it's 2. You go out again, and then you count. Okay, and then you decrement the I. 2. So now you get 6. In your third iteration, you go 6 is still greater than or equal to 0. So you go and count again. And then before you exit the loop, you subtract the count. the I. Now you get 4. 4 is still greater than or equal to 0. So now count as 4. You exit the loop again. And before you're doing that, you subtract the I, which is 2. You go inside, and then you go inside the loop one more time. It's 2 greater than or equal to 0. Yes.
Then
You go and you count. So in this case, I shouldn't do greater than or equal to 0, but I should do greater than, because I found my 5. So all right. So can you go back and remove the equal sign?
Okay. So get rid of this equal sign right here, and let's run through this. Let's see if it works. So this, and it does return me a5.
So it's easier to it's really easy to make mistake with the operation sign, because sometimes it is depending on exclusive and inclusive. So if you can trace the code by yourself before you test out the output or so, or even after, it would be like a good way to check if your logic is correct. So in this case, I started with like a number 10. So 10, including 10, I don't need a 0 at the end. Because if I have a 0 at the end, I would have 11. And in this case, just make a whole mess. But since I traced it, I know that I didn't need the equal sign in my condition. And so I removed that out. So now my whole loop works the way that I wanted it to be.
So one way to do it is how Yen did it. So I actually, based on this hint, saying A divided by B equals C is like saying B fits into A C times. So in other words, in Yen's example, Yen knows that 5 is half of 10 because 5 fits into 10 twice. And actually, in another sense, you could say that 2 fits into 10 5 times. So that's what she took into advantage. She saw that you can fit 2 into an even number an n amount of times. So she just kept subtracting 2, subtracting 2, subtracting 2, and eventually that gives you actually half the number every time you count it up. Every time you count it up. So one way is to see half the number by seeing how many times 2 fits. But in my way, I just took advantage of the fact that, like, how do you know something is half of something? So in general, Yen, how do you know something is half of something?
I divide it.
Yeah. Like you know, something is half of something if you can cut it into 2 halves that are equal. So in a sense, what I can do is something kind of like the opposite of what Yen's doing. Instead of subtracting 2 at a time, I can start with 0, multiply that by 2, and see if it's equal to 10 already. Then if that doesn't work, I add another one, then I multiply that by 2, until eventually it is equal to the number that I want. So you know something is half of something if you multiply it by 2, and then it equals that something you're looking for. So let's try this out. So okay.
I have a question for you, Mark.
What was it?
So you said you start with a 0,
Mhm.
but isn't 0 times 2 is 0?
Yeah. So it's okay, but what I'm saying is you build it up from there. So if it's 0, then you add 1. So now it's 1 times 2, and then that turns into 2. But that's still not the number I'm looking for, which is 10, right? So then I think it's better if I actually write it down first. Maybe it'll make more sense once I show what I mean. So let's open up the other class real quick that I made. So here's another strange divider. First, let me take all this over here. So every time you see this, cannot find symbol class scanner, that just means you have to import it there. and then I want to print out the result right there. So how do we do it my way? Okay. So one way is to say int I equals 0, right? And then while I is not equal to the number I'm looking for, or while I times 2 is not the number I'm looking for, I say I plus plus. And eventually it'll get there. If I'm correct here, well, actually, I could just say I right here if that's the case.
So I'm confused. Shouldn't you do I equals 1?
I think this might be another case of the exclusive or inclusive argument. Let me try to run this in my head first. So let's check it out. So my number is 10, and I start at I equals 0. Okay. So first, I have to check if so first I have to check if I times 2 is equal to the number I'm looking for. So is I times 2 equal to 10? It's not, because 0 times 2 is, well, okay, so let's say I times 2 is right here, right? So right now it's going to be 0. So this is not what I want. So then I increment I. So that's 1. So now is I times 2, which is 1, which is 2, which is 2, equal to the number I want? It's not. So this is going to turn into 2. So then is 4 equal to the number I want? Well, it's not. So I actually want to increment I again, which is 3. So now is 6 the number I want? No. So I have to cross this out, turn this into 4, which turns I times 2 into 8. So then now I look at 8. Is 8 the number that I want? No. So I have to turn this into 5. And is 10 the number I want? So while 10 is not equal to 10, that means it breaks out of this loop. And then it should print out I. So I think it should work, unless I messed up the tracing, right? Like, it can be really easy to mess up the tracing, but let's try it. The real way to know if your code works is to try it in the end. So let's try it out. So if I put in a number, which is 10, then it gives me 5. So it works great. So if you look at the way that my code works, is just, I took advantage of the fact that, you're looking for half the number. So you just started off with a small number like 0, and you keep multiplying that by 2 until you eventually get the number that you want, right? Because that's how you know you're half that number. You just keep adding 1 and then multiplying whatever that result is by 2. And then once you have 10, for example, then you know you're half of 10. If you take 5 times 2, then that equals 10. Like, for example, if it was 100, right, then I would keep going up one at a time from like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then eventually towards 50. And if I multiply 50 times 2, and that equals 100, then that's half of 100. So that's how my rendition of it works.